Good morning, respected judges, fellow educators, and participants. My name is Chua Ching Hao. Today, I will be presenting my project titled Tpack and IDC Theory, a dual framework approach to enhance interest and achievement in mathematics. This project integrates two frameworks, Tpack and IDC Theory, to address one of the pressing issues in education, students losing interest in mathematics. This project was carried out with the support of my colleagues, Kartik and Dr. Mohana. I would like to acknowledge their collaboration and encouragement throughout this journey. This project introduces a teaching module that integrates Tpack and IDC theory, specifically designed for A-level mathematics. The module was developed to address the limitation of traditional exam-oriented teaching, which often fails to engage students. By applying a dual framework innovation, it provides a practical toolkit for engaging lessons that balance academic rigor with interactive learning strategies. Let's first take a look at the core issues. Why are students losing interest in mathematics? To begin with, the first challenge is low engagement, where traditional chalk and talk approaches still dominate the classroom. In addition, there is the issue of exam-centric pressure. For many A-level students, the main goal becomes passing the exam, and this often reduces learning to rote memorizations rather than through understanding. Furthermore, students face a lack of interactivity. Many are not motivated by game-based or activity-driven learning, as they perceive it to be less valuable compared to routine exercises. Finally, there is the problem of weak motivation. Quite often, students cannot see the connections between mathematics and its real-world applications, which makes the subject feel abstract and irrelevant to them. Taken together, these four challenges, low engagement, exam pressure, lack of interactivity, and weak motivation, directly contribute to the decline in student interest and performance in mathematics. To address these problems, a solution was carefully designed with five unique features. First, it has a theory-driven design, as the module is firmly grounded in both the Tpack and IDC frameworks. Second, it emphasizes transformative learning outcomes, ensuring that students gain not only short-term results, but also long-term impact in their learning. Third, the module offers easy-to-use classroom tools, which makes it highly adaptable even for busy teachers with limited preparation time. Fourth, it is also time-saving for teachers, reducing the stress and effort often associated with lesson preparation. Finally, the module is adaptable beyond mathematics, meaning its strategies and approaches can be applied to other disciplines as well. Altogether, these five features make the module not just effective in improving student engagement and achievement, but also practical and scalable for wider educational use. In terms of usability and impact, the module demonstrates five key strengths. First, through the habit loop of IDC theory, it promotes consistent learning habits, helping students build discipline and continuity in their studies. Second, it boosts results and engagement, ensuring that learning is both effective and enjoyable. Third, it integrates technology purposefully so that digital tools are used not only just as add-ons, but as meaningful supports to learning. Fourth, it supports active learning, encouraging students to participate rather than passively receive information. Finally, it encourages collaborations among students, allowing them to learn from one another and build teamwork skills. Taken together, These benefits ensure that the module is not only theoretically sound, but also highly impactful in practice. To further validate its effectiveness, statistical analysis was conducted. In the control group, performance showed improvement in paper 1 and paper 5. However, there was no significant change in student interest. In contrast, the experimental group, which experienced the dual framework guided lessons, demonstrated significant improvement in both performance and interest. These findings confirm that the dual framework approach not only raised academic achievement but also improved students' interest in mathematics. Looking ahead, this project shows clear commercial potential in three areas. First, there is the possibility of applying for intellectual property protections in the future through copyright or trademarks to safeguard the originality of the module. Second, through workshops and training programs, sections can be offered to help teachers adopt and adapt the module effectively in their classroom. Third, educational technology integration provides opportunities to embed the module into digital learning platform, making it accessible to a wider audience. Together, these three avenues ensure not only the sustainability of the project, but also its scalability for broader educational impact. This project has already gained notable recognition. To begin with, it secured third place in UTM 3-minute thesis competitions in 2023, reflecting its innovation and relevance. In addition, the findings have been published in Scopus Index journals, highlighting the scholarly contribution and credibility of the work. These recognitions affirm both the academic value and the practical significance of the project. To conclude, this dual framework module provides a meaningful solution to an urgent problem, the decline of student interest in mathematics. By balancing rigor, interactivity, and relevance, it has demonstrated clear results in enhancing both achievement and motivation. Thank you very much for your attention and interest in this work.